Hello, PreCalc. It is Tuesday's class, so that's the 21st. And tonight we're looking at the sum of a geometric series. Now let me remind you what a geometric series is. It's a series that starts out like with a first term, and then we take a number and we get the second term with that number. So how did I get from the first term to the second? I multiplied. So geometric means multiplying one number to get the next, and another the same number to get the next, and so on. So you can see the number that I chose here for my common ratio is 4. 2 times 4 is 8, times 2 is 32. Times 4, the next term would be 128. So, and we would continue like that. The common ratio is a quantity we called R, and in this case R is 4. So a geometric series can have this sequence. It's a sequence right now with commas, but if I remove the commas and put in plus signs, I have now a geometric series. And when we're working with series, we need to know what they sum up to. And if you recall in your thought cloud, Maddie, you better have been to school today. I was very mad and sad today you were out. So I'm picking on your thought cloud. For the arithmetic series, it was n over 2, a sub 1 plus a sub n. And we showed why that made sense. And now we're going to jump from arithmetic. Again, this is arithmetic. A rat in Tommy's house might eat Tommy's ice cream. Didn't everyone learn to spell arithmetic like that in first grade? Well, anyway. We're now to geometric, where we're not adding a special number to get the next, we are multiplying, and we changed our commas to plus signs. So now we're looking at tonight the sum of a geometric series. So I'm still going to call it S sub n like I did in arithmetic land, but we know tonight it's geometric. So I'm going to develop that, and it's called a proof. Proofs are super cool, and I want to see this one in your comp books. Alright, so we're going to start out with what a sum of any geometric series looks like. If you recall, we start out with a sub 1, then we're going to add the second term, which is a sub 1 times the common difference. The common ratio, R. Then the next term we're going to add has this term multiplied by R, so we're going to get R squared, a sub 1, R squared. Then we're going to add the next term, and so on, until we get to the very last term. Do you recall how many R's are in the last term, the nth term? How many R's should I put there? Well, the first term had no R's, the second term had 1, the third term had 2, the fourth term had 3. So the nth term, this is the nth term, has n minus 1 R's. Is that still fitting on the screen? I hope so. Alright, so maybe I'll move it over a little bit. So we have the sum of n terms is a sub 1. I'm just rewriting because I can't tell if it's on the screen. So, and then there's some terms in between. We're not sure how many. And that is the nth term. So let me erase this. I pulled it over a little closer to the screen view. Alright, so that's that is an arithmetic series in general. Notice I have plus signs and I have all the terms. Each one is multiplied by r until I get to the last term, and we have a sub 1 r to the n minus 1. Now, it's kind of interesting with mathematical proof. I watched a physicist once. He took like a truth that he knew in math, and he just started doing mathematically sound operations onto this one mathematical truth that he started with, and just kept developing, and he went on for pages and pages, just math, 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 math. And finally, he came up to something that was new. So he was creating math, and I can just see how one day, a long time ago, someone took this and said, what if I want to know S sub n, but I want a formula, not a process like this. So maybe they just took that and did mathematically sound things until it fell into their lap. So let's see what we could do. Would it be mathematically sound to take each of these and multiply them by r? Would that be mathematically sound? This is an equation. As long as you multiply r times this side and r times this side, it is mathematically sound. So I'm going to multiply this term by r. Why? Because it's going to lead us somewhere. So this term becomes a sub 1 times r. I'm going to write it underneath of this term, kind of line it up. And then this term, if I'm multiplying it by r, becomes a sub 1 r squared. So I'm going to line it up under here, and so on. So each term will be lined up. Only the first one doesn't have anything under it, because when I multiplied it by r, it became this. So this is sitting there, unmatched. And down here, eventually I'm going to come to a sub 1 r to the n minus 1, but then there's going to be another term. It's going to be a sub 1 to the r to the n, because when I multiply this by r, it'll add one more r, and the exponent will be n minus 1 plus 1, and that will just be a sub 1 r to the n. So algebraically, you should be comfortable with me multiplying everything in here in this first equation by r and coming out with this. All right. Can you tell what I'm going to do? The reason I lined like terms up? Is it mathematically sound to subtract an equation from an equation? It is, because these are equal sides and I'm subtracting it one from one side, one from the other. So I'm taking equal things from two sides of an equation, which is mathematically sound. On this side of the equals, I have s sub n minus, I'm subtracting all of these terms. I'm subtracting all of these terms from these terms. So I'm going to get s sub n, this one right here, minus r s sub n. Let me make sure that's clear. S sub n minus r s sub n. So that's what I get when I subtract this term from this term on the left side of the equation. Now, on this side, when I subtract this from this, gone, gone, gone. Everything in here, gone, gone. So what remains? The a sub 1 on the top equation, which is positive, and the a sub 1 r to the n is negative, because remember I'm subtracting the bottom equation from the top. So there was nothing to take that from, it just becomes a minus a sub 1 r n. Alright, now you can see, I hope, that we have something that is going to be helpful. Remember this whole thing was trying to find a formula for the sum of n terms in a geometric series. So I want to get s sub n. So I see s sub n here and here. Mathematically, when something's in two places, I can get it into one place by factoring it out. So if I take an s sub n out of these two terms, I get 1 minus r. And over here I'm going to factor out an a sub 1, and I'll get a 1 minus r to the n. And now since I'm solving for this, I get the final step where I divide both sides by 1 minus r. A sub 1 times 1 minus r to the n over 1 minus r. Alright, it might look initially like these can reduce, but they cannot. This r to the n prevents us, and this minus sign, if these were multiplied, we could do some canceling, reducing, but since this negative sign is here, we can't. So this is as far as it goes. This is a famous formula. S sub n equals a sub 1, 1 minus r to the n over 1 minus r. I'm just going to give you the theory tonight because my class work is a little bit behind my video work, so this will allow some catch-up time. So you've got the theory down, and I'll show you how to use it when we get to that point, which is probably in tomorrow's classwork. So whenever we get to it, you'll have it right and ready. The formula for the sum of the terms in a geometric series. All right, till we meet again, goodbye.